Okay, so just as before, we have our same four examples that we've been doing for the last couple sessions of notes. So what we're going to do is just going to expand on these a little bit. So I do have my Google Sheet here with all of our information. I'm going to go ahead and highlight really quickly here what is different from before so that you can clearly see what is going on and clearly see the differences. So like I said, everything is pretty much the same. It's just we have a few things that have been modified. Oop, wrong color there. Let's go ahead and do this one. All right, so let's go ahead and we'll start off with this example from before. So if you have your notes, pause the video, get them out, and we'll take a look at this. So what we're going to do is we're going to compare, like I said in the previous video, we're going to be comparing alpha to a p-value. Well, once again, p-value is the probability of getting that critical value. So what I'm going to do is let's go ahead and see here. This is the Pennsylvania IQ score example. So we're at the z-test. So we're looking at this example right here. We already have everything set up from before. Our null, all alternative, our sample mean, population mean, standard deviation, sample size, all that stuff. Okay, so the difference here is we need to find this p-value. Now p-value, to give you more of a visualization of what that is this area, here's our critical value. It is our probability of getting our test statistic. I've been saying p-value, critical value. Sorry, it's probably getting our test statistic. So the formula for that, if you're using Google Sheets, is this value. It's right here. It's a statement. It is since it's greater than, it'll be 1 minus normal dot dist 889 B9, which in this case is our test statistic. 0, 1, true, because 0 is our mean, 1 is our standard deviation, and true just basically stands for it's going to be cumulative. Just know to put true there. And what we're going to do now is going to take this value and compare it to this alpha right here. And clearly, p-value is less than alpha, and that's what I'm going to say right here in this little statement. Since the p-value of 0.036, you only really need three decimal places here, or enough to show that it's less than an alpha of 0.05. And because it's less than, we reject the null hypothesis. There is sufficient statistical evidence, and in the same sentence as before. The only thing that changes right here is this first sentence. Now, in our TI calculators, the way we're going to do that is, go ahead and move this over here. We're going to do this. Let me minimize the calculator just a wee bit. We're going to go to statistics, go to our tests, because we're doing a z-test. I click on that. Our mean is, let's see here, our population mean is 101.5. Our standard deviation is 15. Our sample mean is 106.4 and 30. Okay, and we are definitely dealing with a greater than situation because that's what our alternative hypothesis says. We're going to calculate that, and something I didn't do something right. Let me check that again. Let's test. It's a z-test. Oh, 30, not 3. Okay, so here we can clearly see our p-values are the exact same thing. And this first value is the test statistic, which I am still likely going to ask you for because we're going to have our final exam in some form or fashion. Our p-value, 0.03, that's the next thing that's listed here, and that's the mean and sample size. So right here, comparing this number to our alpha, I think it's easier on a TI-84 in this particular case. So if you can download the program, remember it's free for 6 months if you haven't downloaded it, or if you can download it. If you have a Android smartphone, you can download an app called WabbitMu. It allows you to use a TI calculator on your phone. So I highly recommend that. But anywho, so yeah, p-value here is 0.05, alpha is clearly 0.05, and p-value is less than alpha, we reject the null hypothesis. So that's the way you would check it there. And then same thing on the next example. We have, let's see here, for a specific year, here's our SAT example. Pulling up my notes from there, we have that over here. I'll shift this over. Summary, here's our null alternative, all the information from last time. Now this time, because it's less than, if you're using Google Sheets, the difference between this time and the last one is that you are doing 1 minus. Yeah, last time we did 1 minus because it was greater than. But because it's less than, we don't do that. We don't need to worry about that. And what's equals normal distribution, G9. G9 in this case is my test statistic, comma 0, comma 1, comma true. In close parentheses, and that will give you the p-value for that. In a similar fashion, when we use our calculators, let's see here, I'm going to go ahead and change this over here. We can clearly see that p-value is is greater than alpha. It's 1.18. This is 0.1. Since the p-value of 0.184 is greater than alpha, we fail to reject the null hypothesis. The second sentence remains the exact same. So when I run this test real quick, we're going to go to our z-test because our sample size is over 30 and we know our population standard deviation. So this is 515. I did that really wrong. 515, sorry. Sample mean is 500. Standard deviation is 100. Sample size is 36 this time, and we are dealing with a less than situation because that's what our alternative hypothesis says. And then there we clearly have our p-value right here, matches, and then we can just compare p-value to our alpha, which is 0.05. Sorry, 0.1, and that's clearly greater than 0.1. So since the p-value of 0.184 is greater than alpha, we fail to reject the null. Okay, moving on to our next example. We have a physician claims that a jogger's maximal volume oxygen intake is greater than an average of all adults, a random sample of 15 joggers. We're familiar with this already. We've done this several examples of this. So this is a t-test because our sample size is less than 30 and we do not know our population standard deviation. So now here's my information from before, my null, my alternative, same information, level of significance. Because it's greater than, my normal distribution is going to be 1 minus normal.dist 8b9, which is our test statistic, 0, comma 1, comma true. Same idea on our calculators over here. It's just the only difference now to get that p-value is that we're going to be using a t-test. Sorry, let me go to our test. T-test, which by the way is the more common of the two. And we're going to go ahead and put our information. Our population mean is 36.7. Our sample mean is 40.6. Standard deviation of 6. Sample size of 15. We are talking about a greater than situation because of our alternative hypothesis. And then I think I did that the wrong way. Let me check that again. I think I did something wrong. What did I do wrong? Oh, I put 4.6, not 4D.6. I was going to say that's not right. Now we can clearly see our p-value here. It doesn't exactly match here. I wonder what's up with that. I'll check that out and get back to y'all on that one. But still clearly less than 0.05, comparing that 0.05 value. So we clearly are rejecting the null hypothesis. there is sufficient evidence to suggest that joggers do have a higher volume. You know what? Now that I think about this a little more, it's because I did a normal distribution. This isn't a normal distribution because it's a t-test. It's actually a t-distribution. So I will fix that up and get back to y'all on how to do that. But in the meantime, last one we have here is our proportion test. This is for our last example for female gun owners. So looking at our female gun owners example, we've already done all this stuff before. The only difference now is that here is our test statistic value and we get 0.006, and on a calculator, let's go ahead and run a proportion test. Go to our test tab. A proportion test is number 5, and then we just fill in our information. So it's 0.22. We're saying 11 out of 100 gun owners. We're saying it's less than we think is less than in the area, and we get something's different here. I'll work on that. Make sure I get that back to y'all. But I know this sorry about that. I know this is the right value, and I know it's going to work out just fine. If you have any questions, I'm going to create another video on another topic that we do need to discuss. It's called error, and then I'll go over the homework, which is down here somewhere. But I'll discuss it with you here in a moment.